Some structures on this planet look like a mistake. Not a construction error, but a glitch in the simulation itself. They appear less like architecture and more like a corrupted file, a rendering error frozen in millions of tons of steel and concrete. These giants violate the expectations of the human eye. They push materials to the absolute yield point and ignore the intuitive laws of physics. It is a total visual paradox. Standing before them, one question dominates the mind. Where does hard engineering end and sorcery begin? The first answer is rising in the desert, a new artificial sun. We zoom in. It sits in the Nevada dust like a glitch in the simulation. At 111 meters tall, this is not a concert arena. It is a neural network of concrete and light. Zoom into the surface. At macro range, the skin looks like black hockey pucks spaced inches apart. Pull back 1 mile. Those pucks ignite. The exosphere comprises 54,000 square meters of programmable LED skin. 1.2 million disks working as a single hive mind. From the ground, it mimics the surface of Mars. From space, it looks like a living pupil staring back at the satellites. Inside, the scale shifts from massive to microscopic. A screen wraps 160,000 square feet around the audience. 16K resolution. This is the limit of the human retina. Behind the display, 167,000 speakers hide in the darkness. They utilize beamforming physics. Sound travels like a sniper shot to specific seats. You feel the pressure of the bass on your skin before your brain processes the noise. $2.3 billion, 256 million colors, 4 acres of active display. If here the engineering dominates through the addition of light, the next giant is created through the subtraction of matter. At full intensity, the structure radiates enough lumens to be clearly visible from the International Space Station. While Las Vegas adds pixels, Dubai subtracts the core. Standing 77 meters high, this torus looks less like a building and more like a glitch in the skyline. The interior contains 0 columns, not 1. To prevent the roof from crushing the floor, engineers turned the skeleton inside out. They call it a diagrid. A diagonal lattice of steel wraps the entire structure, distributing gravity's force through the skin rather than a central spine. It is a skyscraper built like an eggshell. The strength comes from the curve. The facade demands surgical precision. It consists of 1,024 stainless steel panels. Here's the manufacturing nightmare. Every single panel has a unique curvature. No repeats. Robots handled the molding, polishing the steel until the seams vanished. The windows are laser-cut calligraphy, slashing through the metal to let sunlight write poetry on the floor. The solid structure represents the knowledge we possess. But the engineering exists solely to frame the empty space in the center, the unknown, a massive silent void. From the silence of Dubai's calligraphy to the sonic boom of Florida, the Seminole Hard Rock is not just a hotel. It is a 450-foot sail anchored in the path of Atlantic hurricanes. The guitar shape creates an aerodynamic nightmare. The wide, flat body acts as a massive catch basin for wind, amplifying lateral forces to critical levels. In a region prone to Category 4 storms, this geometry invites structural failure. To prevent the tower from buckling, engineers poured a high-density reinforced concrete core that acts as a rigid spine. Wind slams into the facade. The air pressure spikes. The glass skin appears fragile, but it is an armor designed for impact. It withstands debris traveling at 150 miles per hour without shattering. While the wind howls against the glazing, the interior remains absolute stillness. Since physical cables are impossible at this scale, the guitar strings are made of pure energy. High-powered light cannons replace steel, firing vertical columns of photons that cut through the humidity. The concrete stops at 450 feet, but the light extends the instrument to 20,000. While Florida entertains with photons, Taiwan twists concrete into a biological spiral for the sake of survival. This is the Tao Zhu Yin Yuan, a structure that mimics the double helix of DNA, not for beauty, but for mathematical efficiency. The engineering is rigorous. The floor plate rotates exactly 4.5 degrees at each level. Over 21 floors, the tower completes a full 90-degree twist. This geometry exposes every unit to the sun and creates cantilevered terraces for 23,000 trees and shrubs. The sensation is disorienting. The smell of ozone and wet soil hangs in the air, masking the metallic scent of the metropolis below. This biomass absorbs 130 tons of carbon dioxide annually, but beneath the organic skin lies a fortress. Taiwan sits on the ring of fire. Standard foundations would crack under the torque of this twisting mass during a tremor. The engineers installed a seismic isolation system identical to those used in nuclear power plants. 68 friction pendulum bearings separate the building from the earth. When the ground shakes, the foundation moves, but the tower floats. The steel skeleton remains rigid. The structural integrity is so extreme it changes the logistics of luxury. A reinforced freight elevator, smelling of hydraulic fluid and money, waits at the ground floor. The doors slide shut with a heavy industrial thud. A resident drives a 2-ton supercar into the lift, ascends the twisted core, and parks the vehicle directly inside the living room. From the biological spirals of Taipei, we cut to the absolute, unforgiving geometry of the Emirates, the Dubai frame. No curves, no organic flow, just a 150-meter rectangle slicing the desert sky. 2 towers support a 75-meter bridge that acts as a physical timeline. Look north and you see the dust and clay of old Dara. Look south and the chrome spikes of the modern skyline rise from the sand. But the true engineering marvel here is designed to induce panic. The bridge floor utilizes advanced smart glass technology. At rest, the panels are a comforting opaque gray. Safe, solid. You take a step. Pressure sensors trigger a voltage charge through the laminate. Inside the glass, liquid crystals align in milliseconds. The gray haze vanishes. The floor disappears. Suddenly, your brain registers nothing but a 50-story drop to the concrete below. The only thing separating you from the abyss is an invisible layer of chemistry. If the Dubai frame is a shrine to perfect vertical symmetry, Singapore detonates that logic entirely. No isolated needles piercing the sky, just a calculated explosion of geometry. This is the Interlace, 31 identical apartment blocks, 6 stories per unit, stacked not in a line but in a hexagonal web that seemingly defies gravitational intuition. It looks like a game of Jenga abandoned by a giant, but this visual chaos is actually a precision aerodynamic machine. The gaps between the blocks are not empty space, they are intakes. As the heavy, humid tropical air hits the structure, physics takes over. The Venturi effect. When the wind is forced through the narrow constrictions between the angled blocks, it accelerates instantly. Velocity increases, pressure drops. The building creates its own cooling breeze, slashing the need for air conditioning in a city located 1 degree north of the equator. But how does this stack of concrete bricks not crumble under its own dead weight? The answer lies in the intersections. This is not just stacking, it is bridging. Massive structural trusses are hidden within the walls of each block. They channel the gravity load of the upper volumes down through specific transfer points where the masses overlap. The weight does not go straight down, it zigzags through the frame until it hits the foundation. While the Interlace uses complex geometry to solve a climate problem, our next stop abandons subtlety entirely for a literal interpretation of a household object. While the Interlace relies on abstract geometry, engineering in Central Ohio abandons subtlety for absolute literalism. This is not a hallucination. It is a standard maple wood basket magnified 160 times. 7 stories of corporate office space disguised as a woven container. But the whimsy of the design creates a massive structural hazard. 2 steel handles arc over the roofline. They weigh 150 tons. That is the equivalent of 2 diesel locomotives suspended in the air. Beneath this heavy steel lies a fragile glass atrium. In a freezing Midwest winter, moisture naturally condenses on cold metal. Sharp daggers of ice form on the handles. Gravity pulls them down. A single shard dropping 7 stories would shatter the atrium glass like a gunshot. To prevent catastrophe, engineers turned the structure into a radiator. They ran heating elements through the core of the handles. The steel radiates heat against the winter sky. Snow touches the surface and vanishes instantly. An internal heating system keeps the metal warm enough to melt precipitation on contact, protecting the people below from a lethal rain of ice. While Ohio relied on heavy masonry to mimic woven wood, engineers in Hyderabad turned to a colder, harder medium, stainless steel. The National Fisheries Development Board headquarters is not merely a zoomorphic curiosity, it is a 4-story lesson in complex metal cladding. Standard flat sheets cannot follow the organic curves of a biological form without buckling. To create this metallic skin, builders in 2012 had to abandon mass production. Each panel required individual molding to fit the specific radius of the hull. The result is a seamless shell of polished alloy. Under the Indian sun, the surface acts like a chaotic mirror. Blinding flashes of white light bounce off the steel scales, rejecting the heat. The only break in this armor is the eye. A circular aperture of blue glass filters the intense radiation before it reaches the workspaces inside. The structure stands silent in its shimmering coat. The giant fish in India stands firm on solid legs. But in Hamburg, engineers engineers challenged gravity with a structure that looked ready to topple at any second. The Astra Tower defined instability. It resembled an inverted bottle, a concrete mushroom sprouting from the pavement with a dangerously narrow base. Conventional skyscrapers rely on a perimeter skeleton to hold the weight. This design deleted the outer legs. Every ounce of structural stress channeled into a single, massive axis of reinforced concrete, the central core. From this rigid spine, the floors cantilevered outward like the cap of a fungus. This engineering trick allowed the building to occupy a minimal footprint on the crowded ground while expanding dramatically in the air. An inverted pyramid of glass and steel. It created intentional vertigo, a visual lie. The center of gravity was calculated to the millimeter to prevent the top-heavy mass from crushing its own neck. The structure itself has been erased from the skyline, demolished. Yet the lesson in load distribution remains. Gravity eventually reclaimed the site, bringing the concrete giant down to dust. While Hamburg challenged the vertical limit, a quiet field in Suffolk mocks the horizontal plane. This is the balancing barn, a 30-meter steel structure that refuses to settle. It projects into the void like a residential diving board. The engineering relies on a massive discrepancy in mass. Exactly half the house has no support. To keep 15 meters of steel from tipping over, engineers utilize the fulcrum principle. A dense, reinforced concrete core anchors the landlocked end. It weighs significantly more than the floating section. The heavy tail holds down the light nose. Walking through the corridor creates a physical paradox. You move from the safety of the concrete anchor toward the suspension. At the furthest point, the floor vanishes. A thick sheet of glass reveals the empty air and grass far below. Your brain signals a fall. The structure remains silent. No creak of stressed metal, no vibration. We are literally living on the edge. These floating monoliths look like glitches in reality, but gravity is not a simulation. To visualize these structural extremes, we utilized advanced neural network rendering throughout this breakdown. This technology allows engineers to test failure points virtually before risking millions of dollars on actual steel. The line between digital art and physical danger has vanished. If you want to decode the mechanics behind the impossible, join the channel. Press the subscribe button now.